looking at this warm-up, we have a linear model and an explicit model, or an exponential model. The pattern on the first one is plus 5, plus 5, plus 5. So what type of equation is it? It's a linear equation. So what type of sequence is it? Arithmetic sequence. Okay. So in an arithmetic sequence, and when we talk about sequences, we always start at a sub 1, whereas in equation form, it makes more sense to talk about a sub 0, but sequences usually start at 1. So here, we need to write a recursive and an explicit. A recursive is an equation that builds on last year. So you need to state the beginning. In this case, a sub 1 equals 3. And then a sub n equals a sub n minus 1. So to find any value, you take the previous value, and what's the pattern? Add 5. Brooklyn, does that make sense? Okay. This is recursive, meaning we relied on the previous value to calculate a future value. Okay. So for the explicit, it's y equals, and for a linear equation, it's mx plus b, which you've been dealing with for years now. So what is the mx plus b equation? 5x, and then there's kind of a trick. I know that we're going up by 5, but the explicit model always relies on year 0, but I don't have year 0. So I need to back up and find year 0 by undoing this plus 5, so I subtract 5, and I get minus 3. That is the explicit equation. Oh, apparently I don't know how to do my subtraction. Minus 2. You have no proof, except for perhaps this video. Okay, so what is the difference between a sequence and a series? A series is a sum of a sequence. So if I wanted to find S sub n, which is the series, the sum of the sequence, up to a particular number, does anybody remember the formula for an arithmetic series? N times a sub 1 plus a sub n over 2. Okay? So now we move on to exponential. This is an exponential function. And what type of sequence is created using an exponential equation? A geometric series. Now, why they made this distinction, I never figured it out. That's just what we call it. Who knows why? Okay, so to find a recursive model, we do the same thing we did on the top. A sub 1 equals 3. And then a sub n equals a sub n minus 1. What's the pattern? Last year times 2, last year times 2, previous term times 2. So we're just going to take the previous value and multiply it by 2. Okay? So the explicit formula is in the form y equals b times m to the x, where b is year 0, but I don't have year 0. So how am I going to find year 0? Divide by 2, which is 1.5. So y equals 1.5 times, what's my common ratio? 2 to the x. Okay? Brooklyn, you all right so far? Yes? Yeah, anytime you multiply by a common ratio, it's an exponential function, and the sequence is called a geometric sequence. Yeah, good. That's a good question. Okay, so what is the formula S of n for a geometric sequence? Geometric series, sorry. A sub 1, and sometimes it's just a. Sometimes they don't put a sub 1, they just put a. Times 1 minus r to the n over 1 minus r. Now, if I were to give you these two summation formulas, how could you figure out immediately which one is which? There are a couple different ways to view this. Go ahead. Good. This one has an exponent. So it must be the exponential version. Sadie? What's your question? No, it's plus. It's plus. No, it should be. I don't think you have. I think you've been doing it right. That was several days ago. We've been doing this one for the last few days, which is minus. So I think you're just confused. Because when we did it, you totally got it. So I think you're just mixed up now. Another way is R represents the common ratio. So that must be the exponential version. Okay, so let's calculate S sub 8 for both of them. So I want to figure out S sub 8 of the arithmetic sequence. What is N? 8. So 8 times, what's A sub 1? 3. Plus, what's A sub N? I don't know, right? This pattern just continues. How am I going to figure out the 8th term? I could use the recursive, right? I could just do plus 5, plus 5, plus 5, but that's annoying. Don't want to do that. So Chad says we use the explicit. How do I get the 8th term with the explicit formula? Just plug in 8. 5 times 8 is 40, minus 2 is 38. So plus 38, and I divide that by 2. Well, 8 over 2 is 4, times 3 plus 38 is 41, which is going to be 164, I believe. So that equals 164. Okay? How do I find S sub 8 on the exponential, the geometric? Do I know A sub 1? What is it? 3. The first term is 3 times 1 minus, what's R? 2. So 1 minus 2 to the 8th over 1 minus 2, which is negative 1. So let me bring my calculator over. So 3 times parenthesis 1 minus 2 to the 8th. I'm going to divide that by negative 1. And I get 765. So how come, so I got 765. How come the arithmetic is so much smaller than the geometric if I did the same number of terms? We're multiplying by 2, so my sequence is getting bigger really fast. So even though I did the same number of terms, the geometric series is often bigger. Now, having said that, sometimes geometric series stop. They stop getting bigger. And that's something we're going to talk about on Tuesday. Sometimes a geometric series is shrinking so fast it stops growing altogether. Okay? All right. Anybody confused about that? You guys are doing so well. That's the common ratio. Times 2, times 2, times 2. Yeah. Okay? All right. What if I had... yeah, you can write it down. They will be on the web, but I'm not going to have you turn them in. So this says I have a sequence. The sequence is 16, 20, 24, and on. What type of sequence is it? It's linear, which means it's arithmetic. And I want to know if I add up everything from 16 up to 248, what is that going to equal? So first I need to figure out arithmetic. Then I know which formula to use. S sub n equals n times a sub 1 plus a sub n over 2. Now, everything we do today is going to be arithmetic, just as a heads up. So we're always going to be using this formula. Do I know n? No. Do I know a sub 1? Yes. Do I know a sub n? Yes. Do you get that? A sub n is the last number in the series. So this is a sub n. Wherever you stop is a sub n. A sub 1 is the first one. Right. So all I need to know is this is a sub 1, a sub 2, a sub 3, dot, 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 a sub what? If I can figure out this number, which tells me how many terms are there, then I can solve for the sum. How do you recommend we do that? That'll work, but you'll always be off by 1. Do you see why? If you do that, you'll find the number of terms. Well, actually, I don't know. We'll try that in a second. That will work, but we may or may not have to adapt it. Let's see. Okay. Use the explicit formula. Y equals mx plus b. Okay. Do I know m? What is it? What's my increase? 4. X. Do I know b? It's not 16. It's 12. Because this is a sub 1 and b is always a sub 0. So this is plus 12. Do I know the y value? Well, I want to know when y is 248. So 248 goes here, and I solve for x. So minus 12, 236 equals 4x. Divide 4. 4 goes into 225 times, and it goes into 36 9 times, so it must be 34. Is that right? Was I way off? 25, oh, 50, sorry. 50 and 9. So x equals 59. What does that tell me? There are 59 terms. Okay? So 59 goes here. 59 times 16 plus 248 over 2. This is going to be really big. What do you get when you plug that in? Oh, it's not too big. 7,788. Wow. Okay, did everybody get that? Brooklyn, you okay? Does anyone want to see another one of that type? One more? Okay, let's do one that's not quite so big. So so I want to know, what does this equal? I know a sub 1. I know a sub n. I just need to figure out n. Oh, did your way work? It's 1 off every time. Yeah, okay. So we'll show you what Josh did on this one. And it works, and it is a little bit easier. It takes less time, but you're always off by 1. So I'm going to have y equals, what's my first difference? 3. So 3x, what's a sub 0? 9. And I want to know what this equals when y equals 63. So I'm going to subtract 9. 54 equals 3x. Divide 3, 18. Is that right? Okay. So 18 tells me this is a sub 18. There are 18 terms in this series. So 18 times the first term, which is 12, plus 63 over 2. Well, 18 over 2 is just 9 times 12 and 63 is 75. 6. Is it 675? Okay. That's the sum. So Josh, explain how you did it. So you want So Josh wants to know, how many times did I add 3? That's what he's calculating. But you have to remember there's a plus 3 right here that's not included. So either you include that in the beginning and you subtract off the difference at the end, or you take your answer and you move it by 1. So he's saying, well, I know that the difference between 63 and 12, 63 minus 12 is going to be 51. So this is how much has been added, right? So 3 plus 3 plus 3 all over is 51. So he's going to divide that by 3, and you get what? 17. So that tells you how many plus 3's there are, but the only trouble is this number is off by 1. So you add 1 to that, and you get 18, which will give you the same answer. Yeah, the other way to do it is to start here at 9, and instead of 63 minus 12, just do 63 minus 9, and that'll get you the answer. Because that's exactly what we did, right? 63 minus 9 divide 3. We just did it in equation form, and he just reasoned it out. So that will always work if you start here. Yeah. So if you prefer that way, go ahead. But just don't forget, you need to start with this number. Either that or you add 1 to your answer every time. Okay. So let's look at a new version. Let's do 20. No, 10's good enough. Is this arithmetic? Yes. How do you know it's arithmetic? There's no exponent. Good. It's a linear equation, mx plus b. So do I know n? N is 10. So 10 times. Do I know a sub 1? I don't know it yet, but I can figure it out. I just plug in 1. So 6 times 1 is 6, minus 15 is negative 11, plus, oh my gosh, you're so picky. Sorry. Okay, and then we plug in 10, 60 minus 15, 45. I'll get one of these right. So this says, if you take this equation and you plug in 1, and then you plug in 2 and 3 and 4 and 5, all the way up to 10, that's the sequence. So the sequence would be negative 9, negative 3, 3, 9, 15, and so on. So this is, I plug in 1, I get negative 9. I plug in 2, I get negative 3. I plug in 3. That's what it's creating, but we're skipping all that. So this just says, add up all of them from a sub 1 all the way up to a sub 10. But the nice thing is, with the formula, I don't need to write any of that down. All I need to know is how many numbers there are, and then what the first number and the last number are, and the formula will do the summation for me. Okay? So 10 is the number of terms. A sub 1 is the first term. That's what I get in the equation when I plug in 1. And this summation machine says start at 1 and stop at 10. So I plug in 10 to find my a sub n, which is 45. Sorry, I really skimmed over that. Does that make sense now? Then I divide this by 2. So it's going to be 5 times 36. I don't even want to try to do that in my head. 150, 180. Okay. So 180 is the summation of that. Okay? So on your homework tonight, you either are going to be given a sequence and you need to find n so that you can create the series, or you're given a summation machine and you need to calculate a sub 1 and a sub n and then plug that into the formula. You want to do another one of these? Okay, that's fine. So let's do, yes, everything today is arithmetic. 4x plus 10 from from x equals 1 to 5. So what is n? 5. So 5 times, what's a sub 1? 6 plus, what's a sub n? Negative 10. Does everybody see how I got those? 5 is the n, that's at the top of the sigma. And then I plug in 1, negative 4 times 1 is negative 4, plus 10 is 6. No, you could, it wouldn't hurt. Or you could just put minus. Yeah, either way, it'll work. And then divide that by 2. So 5 parentheses 6 minus 10 divided by 2. Why is that so small? It's not. Only geometric sequences can jump back and forth. So why is this so small? Okay, I'm decreasing, but my last term was negative 10, and my answer is negative 10. How can that be? Not necessarily. What's that? So, and actually I start at 6. So it's 6 plus 2 plus negative 2 plus negative 6 minus 10. Well, what's going to happen to all those? They're going to cancel. So the answer was just negative 10. So arithmetics don't jump back and forth, but they can start positive and end negative. And that's what happened here. Our sequence is going down, and it actually dropped into the negatives. So that canceled that, and that canceled that. And a lot of times that'll happen. In a geometric, sometimes it bounces back and forth. But that cannot happen in arithmetic. Okay, your assignment today is page 41. Yes. So if you need to write it down there, you can also go to the website. There's a link to the book on the website and find page 41. The whole thing. It's only 15 problems. It's page 41.